In this video we're going to look at how we can calculate the area of a triangle for non-right angled triangles using a method involving trigonometry. So we can find the area of a triangle if we know the lengths of two of the sides and the angle between those sides, so as in this case here. And we use the formula that the area is equal to half AB sine of C. So A and B are two of the lengths, and the capital C is going to be opposite the lowercase c, so it's basically opposite the length that we're not using. So in this first example it's this length here, and that is always going to be in between the other two. So I have all the ingredients I need here to use this formula, so I can straight away just substitute in. So the area is equal to half of 4 multiplied by 7 multiplied by sine of 22. Now I can evaluate that immediately on my calculator. So here I have a half multiplied by 4 multiplied by 7 multiplied by sine of 22. So 5.24 if I do this to three significant figures, and because this is an area and my initial units are centimetres, this is going to be centimetres squared. In this second example I can't immediately use the formula because although I have one angle and two sides, I do not have the angle in between two sides. So I'm going to have to find some more information out first, and I've got two options here. I can either find this missing length, and then I've got two lengths and the angle between them, or I can find out this angle, and then I have two lengths and the angle between them. So if I want to find the missing length, I'm going to use the cosine rule, which I might be tempted to use if I knew this angle, because it was a lot easier when you know the angle opposite the length you're looking for. Although of course if I had this angle I would be able to use the formula straight away. So I'm actually going to use the sine rule. So I'm going to call this angle A for a minute and this one angle B. Now for the sine rule I need two lengths and the angles opposite. So I've got this length and this opposite angle, which is one pairing, and so this length and this angle is going to be the other opposite, the other pairing I'm going to use, which initially is not great because I actually would like the other angle. Anyway, let's work out what we can. So we know here that sine of 96 divided by 9 is equal to sine of B divided by 5. So therefore sine B is 5 sine 96 over 9. So B is going to be arc sine of 5 sine 96 over 9, and I'm going to evaluate that. Which is 33.5, and so A is going to be therefore 180, subtract the 96 that was given, subtract the 33.5 I've just worked out, and I'm using the answer key here for a good reason, and that's because this was a rounded value and I don't want to lose accuracy at the end. And so that gives me 50.5 degrees as a value for A. But because this is a rounded answer, what I'm actually going to do is I'm going to take my answer and I'm going to do shift store A. So I'm going to store that in memory A. So when I use it later on, I'm going to use a nice accurate answer. So now I can find the area. So the area is equal to half AB. So half 5 times 9 multiplied by sine of the angle between them. So I'm going to put sine 50.5, but when I put this into my calculator I'm going to use my stored value as that will not lose any accuracy. So half multiplied by 5 multiplied by 9 multiplied by sine on my angle, so sine alpha A. And then when I get my value, I've got 17.35, so to three significant figures, I'm going to call that 17.4 centimetres squared.